Hello, class, and welcome to week one. Today, I want to go over the week one formative assessment, which is on significant figures. A couple of ways you can find this, either going to your homepage and then you want to scroll down to week one and you click on that, and then you go down to where you see the week one formative assessment. You can also find it on the assignments tab here on the left hand side. And so we want to go to our week one formative assessment, and I'm going to show this in preview mode so that you can see it. It'll come up as an actual assignment when you're clicking on it. All right, so let that come up. All right. So this week we are working on significant figures. And so in this first chart, it gives you the rules for significant figures. And so we have non-zero digits. So if the number is not zero, like 3749, then all of those numbers are significant. Then we have leading zeros. These are zeros before a number, so 0.0056. All of these zeros are what we call placeholders. They are leading zeros that tell you the value of the number, but when we're doing calculations, they are not significant, so only the 5 and the 6. And let me tell you, when we're talking about significant figures, we are looking at these numbers to determine which numbers are important for us for our calculation. Okay, and we're going to talk a little bit about that when I get to the calculations portion. So we're not saying that these zeros don't have value or they're not important for the number, but when we're doing rounding for our calculations, we don't use those to determine how to round our final answer. Then we have what we call captive zeros. These are zeros between two numbers. And so 5.007, those two zeros are between the 5 and the 7. It doesn't matter how many zeros are in between non-zero numbers, they are all considered to be significant. So there are four here. We have trailing zeros. These are zeros after the number. And so there's different types of trailing zeros. And so I gave a few examples here so that you know the different types. And the rule is that they're counted only if the number contains a decimal point. So only count the zeros located after a number. So if we have the number 100, you don't see a visible decimal there. So only that one is significant. But say we take that same number and we put a decimal at the end of that zero. Because that decimal is present, it makes those two zeros significant. So we have three significant figures. If we add a zero after the decimal, so we have 100.0, even the zero after the decimal is still significant because it's still a trailing zero. So we have four. If we have 0.0100, these zeros in front, those are our leading zeros. Remember, they're not significant, but the trailing zeros, because that decimal is there, are significant. So the 100 at the end, those are significant, giving us three significant figures. So what if we have a number in scientific notation? Scientific notation numbers, we look at the numbers before the X or that times symbol. All of the numbers listed are significant. So 1.7 times 10 to the negative 4. The 1 and the 7 are significant, giving us 2. 1.30 times 10 to the 8th. The 1, the 3, the 0 are significant, giving us 3. So sometimes when we're doing calculations and we want to show a number has only two significant figures, but say the number is 100, okay? 100, remember, only has one significant figure. But if we want to show that 100 has two significant figures, we can put it in scientific notation, and then that would be 1.0 times 10 to the second, okay? So we use scientific notation if when we're rounding a number, we can't write it as a regular number to show the significant figures, we can always put it in scientific notation, all right? So what about when we're doing calculations? So now that we know the rules, now we want to take it a step further and look at doing actual calculations. So the rules are when adding or subtracting, we round the result to the same number of decimal places as the least number with the least number of decimal places, okay? And so, all this information is from your textbook, and so you can find this information there. And so we're going to look at some examples of what that means exactly. Then when multiplying or dividing, we round the results to the same number of digits as the number with the least number of significant figures. So adding and subtracting, we're looking at decimal places. Multiplying and dividing, we're looking at significant figures. And then the rules for rounding. So if the digit to be dropped, the one immediately to the right of the digit to be retained is less than 5, we round down, meaning we keep the number the same. So we leave the retained digit unchanged. If it is more than 5, we round up, so we increase the retained digit by 1. If the drop digit is 5, and it's either the last digit in the number or it's followed only by zeros, then we round up or down, whichever yields an even value for the retained digit. Okay? If any non-zero digits follow the dropped 5, round up. The last part of the rule may strike you as a bit odd, but it's based on reliable statistics and is aimed at avoiding any bias when dropping the digit 5, since it is equally close to both possible values of the retained digit. Okay, so let me show you examples to make that a little bit more clear. So we have, for these following examples, we want to round each of these numbers to three significant figures. Okay, so we have 0.02867. We want three significant figures. So we remember those two zeros, those are leading zeros and they're not significant. So we have 2, 8, and 6. So the 6 is the last number that we're keeping. So we look to the next number to see if we round it up or we round it down. So next to it is a 7. So it's greater than 5, so that means we round up. So the new number becomes 0.0287. All right. So now we're going to look at the next one, 18.3384. So all of these are non-zero numbers. So we're going to look for three significant figures. So we stop at the 3. That's the last number that we're keeping. So we look next to it, which is a 3. That 3, because it's less than 5, tells us we round down, or in other words, we're going to keep the 3 as it is. So it's 18.3 for our answer. So let's look at the next one, 6.8752. So the last number that we're keeping is the 7. So we look next to it, which is a 5. Okay, so remember we have that rule for the 5. Okay, so the drop digit is 5 and a non-zero digit follows it. Okay, so that means that we're going to round up. So it becomes 6.88. So let's look at another one. We have 92.85. So we have an 8 is the last number we're keeping. We're dropping the 5. So the drop digit is 5 and retain digit is even. So that means we keep it the same, 92.8. Okay. So that's to give you examples of rounding. But now let's look at examples of the calculations. So we're adding and subtracting. Remember, we're looking at the least number of decimal places. So we have 1.457 that has 3 decimal places. 83.2 has 1 decimal place. So when we add it, we get 84.657 because we don't want to round to after we add. And then it rounds to 84.7 because we want one decimal place. Okay. So the next one, 0.0367 has one, two, three, four decimal places. 0.004322 has one, two, three, four, five, six decimal places. So we want to round to only have four decimal places. So when we subtract the two numbers, we get 0.032378. We are rounding this to four decimal places, so we get 0.0324. Okay. With multiplying and dividing, we have our significant figures that we're looking at. So if we look at this answer, we have 4.36. We're multiplying it by 0.00013. 4.36 has three significant figures. 0.00013 has two significant figures. And so when we multiply the numbers, we want to round it to the least, which is two significant figures. So when we multiply, we get 0.0005668. We want to round to two significant figures. Remember, those leading zeros are not significant. So we get 0.00057, right? Then we want to look at division. 12.300, those are trailing zeros, and there's a decimal visible. So that is five significant figures. 0.0230, those leading zeros aren't significant, but the trailing zero is because of that decimal. And so we have three significant figures. When we divide the two numbers, we get 534.78261. We want to round it to three significant figures, so we get 535. Okay, so that's our significant figures. The next part, okay, so that's part one. The next part is factor label method. So with this, we're looking at what we call dimensional analysis. And this is our way of looking at our calculations and how we set up the problems. And so, for example, okay, nine we have is our number, okay, because with every problem that we do in chemistry, when we're dealing with our measurements contain the number and they also contain the unit. So, for example, 3 grams, the gram would be the unit, okay? It tells you what the number three represents, okay? And so if we don't use the number and the unit, then the number itself is just pointless. Like, for example, if you were saying something weighs 9 pounds, if somebody asks you how much it weighs and you say nine, that could be 9 pounds, it could be 9 grams, it could be 9 kilograms, it could be all kinds of things. And so you have to use the unit because it's very important. When we are looking at calculations, because our measurements contain both the number and the unit, when we're doing our, say for example, we're multiplying, okay, we've looked at this 2 feet times 2 feet. We're not only multiplying the numbers, but we're also multiplying the unit. So 2 times 2 would be 4, feet times feet would be feet squared, okay? The same thing if we're dividing units. If we divide the same unit, they cancel out. If you're not dividing the same unit, like for the unit for density, where we're dividing grams and milliliters, we can't cancel anything because they're not the same unit. So we just put grams slash ml. Okay, and we use both units for our final answer. Just the this the same as miles per gallon. Okay, we use that slash. That tells us that both units are present and they're being divided. Okay. So if we are looking at dimensional analysis, we can use this to go from one unit to the next, and the unit that converts the original unit to a new unit, we call that the conversion factor. And so if we start off with 10.0 grams of water in the form of ice, and we want to go from grams to milliliters. And so in order to do this, we would use our density for ice. Okay. And so if we look at this, we have 10.0 grams of water and ice times milliliters over 0.917 grams. The grams that we start with, we want to put the same unit on the bottom. So this is our conversion factor, grams to milliliters. And so because we're starting with grams, we want grams to go to the bottom. If we were starting with milliliters, we would flip this conversion factor so that the milliliters would go on the bottom. So then whatever's on the top, you're going to multiply everything on the bottom, you're going to divide. And so you take 10.0 divided by 0.917 and we get 10.9. 10.0 has three significant figures. 0.917 has three significant figures. So when we divide them, our final answer should have three significant figures. And so that was using our numbers. But let's look at our units because our units, remember, are part of the calculation as well. So because we have grams on the top and grams on the bottom, they're going to cancel out, and we're left with just our milliliters. So part three deals with the moles. So our mole is not the little cute furry creature, but it is a unit of measurement in chemistry. And a mole has two definitions. So one is that the mole is equal to 6.02 times 10 to the 23rd, and we call it things. Things meaning that depending on what we're looking at, this unit can change. So if we're talking about a particular element, then the things becomes atoms. If we're talking about a molecule or a compound, then it's molecules. Okay. The other thing, oh, one thing to note that this number is known as Avogadro's number. Right? And then if we are looking at grams, 1 mole can equal 2 grams as well. And the grams is based on the numbers in the periodic table. And so in the periodic table, the number that is listed at the bottom is known as the grams for 1 mole. So if we're looking at silver, silver has the symbol of Ag in the periodic table. And so if you look at Ag in the periodic table, you find that silver is 107.86. That's the number that's listed below the chemical symbol in the periodic table. And that represents the number of grams in 1 mole. And so if we start off with 100.0 grams of silver times 1 mole of silver over 107.86 grams of silver, then you are looking at how many moles you want to find. So because the grams are on the top and the grams are on the bottom, they're going to cancel out. You're going to take the 100.0 divided by the 107.86, and you get 0.9271 moles of silver. So let's look at significant figures. 100.0, remember we looked at this example before, that decimal makes all of those trailing zeros significant. So that gives you four significant figures. 107.86 has five significant figures. Remember that zero is captured between the 1 and the 7, so it makes it significant. But when we divide, we always want to go with the least. The least in this case is 4, so we have 0.9271, which has four significant figures. Okay. So that is to give you some information that will help you answer the questions, all right? And so the questions there are, if we look here, we have a total of 12 questions, okay? Some are calculations, some are just creating numbers and figuring out significant figures. So, number one, we want to create random numbers for actually for one and two, and just to see how many sig figs we have. Are the zero significant? Why or why not? And then two, we're practicing rounding numbers so that you can get the hang of rounding. And then for three, we're creating numbers with decimal places. You're going to take that number and add them and see how many decimal places we're rounding to based on the rules for adding and subtracting. And then for number five, you're getting creating numbers that you're going to multiply and divide in number six. Okay. So then when we get to seven, we're actually doing some calculations with given numbers. And so make sure that you are paying close attention to your significant figures because you want your answer to reflect that. In your in the box with any calculations that you're doing for this lab, you do need to show all your work for full credit. Okay. And then you are doing another calculation here. And with each of these problems, you will have access to a calculator. Let me see if it shows it. Somewhere shows the calculators. It should show you a scientific calculator. Right now, mine is not showing up, but I will make sure that. Oh, there it is. Okay, so here you'll see a calculator. Okay, you just click on that, it should pop up. I'll make sure that all the ones with calculated calculations have the little calculator pop up. And so you want to make you can use this or you can use your own calculator, either way, so that you can do your calculations. Okay, and I'll make sure that they all show. Oh, here's one that shows the calculator. Okay, and so you want to make sure that you use a calculator for these calculations. But you do want to show all your work within the problem, even though you are using a calculator. Okay. All right. And then when you get to here, you're going to look up the atomic weight of any atom in the periodic table. So you can choose, okay, which one you want to use. And then you're also going to choose how many grams you want to start with. Okay. One thing that I do want to note for this one, when you're picking a random number for your grams, make sure that you have at least two significant figures. Okay. Then you're looking at the atomic weight for gold, and you start off with 26.9 grams. You want to calculate your moles. And then we want to take your moles that you calculated in 11, and you want to use Avogadro's number to find the number of atoms. And you want to make sure that you show your work, okay, for that. And there is a calculator here, okay, that will help you do the calculation. All right, so one thing that I do want to mention, okay, because we are using scientific notation here, and I'm looking on this calculator to see if it does include our symbol for scientific notation. And I see that it doesn't. All right. So when you want to do 6.02, all right, times 10 to the 23rd, there is this E button, okay? That E button, let me make sure this is the right thing. Nope, it is not. All right, so this is not what I'm thinking it is. So you're going to do 6.02 times 10 to the 23rd. When you do that, okay, it is very important that you put the number in parentheses so that, let me see. There we go, 23rd. Okay. So that your calculator knows that this is all one particular number. And say we want to multiply that by 3 0.2, okay? Then it's going to give you this number, 1.9264 E plus 24. Okay, that E means times 10, okay? So that means times 10 to the 24th. That plus means that the 24 is positive, okay? And so I multiplied it by 3.2. So that had two significant figures. So your final answer would be 1.9 times 10 to the 24th. Okay? So let me do that one more time so that you see it. So remember, you want to put your 6.02 times 10, and then you use this x to the y button to the 23rd, close parentheses, and then times 3.2, and then that's equal to, and then because 3.2 only had two significant figures, it would be 1.9 times 10 to the 24th. Okay? All right. So I want to make sure that I showed you that. Once you complete the lab, you're going to click submit. And then if you have questions, please let me know. Thank you.